Hello everyone, and welcome to the Abarso ASAP YouTube channel. Throughout the duration of the school closure, we want to make sure you are up to speed on the topics and themes that would typically be covered in your classes. For this video, we will be diving into the fundamentals of factoring polynomials. By the end of this lesson, you will be able to factor polynomial expressions using greatest common monomial factoring, and you will be able to factor quadratic expressions with leading coefficients of 1. Once you have mastered these concepts, you will be able to apply them in tons of different ways. Check out the links in the description below to see just how useful these concepts are. Don't be overwhelmed by the names of the topics we're covering today. You are already proficient with many of the background skills needed to be successful. Before we begin, pause the video and make sure you have access to a pen or pencil and a notebook to make the most of this lesson. Let's get started with the do now. The do now should be a review of skills you have already mastered. I just want to get your mind moving in the right direction. For the following 4 problems, I want you to find the greatest common factor, or monomial, among the given examples. Remember to find the greatest common factor between monomials, take each monomial and write its factorization. Then identify the highest factors common to both monomials. If you're confused, think about how you reduce or simplify fractions. This is a common application of GCF. At this point, I would pause the video and get started on the do now. Let's go through number 1 in detail to make sure you understand. When finding the GCF, it is always a good idea to list the factors, the numbers we multiply together, of the coefficients in the problems. So for number 1, let's deal with the coefficients first. The coefficients of the 2 monomials are 3 and 24. To perform the factorization for 3, ask yourself, what do I multiply together to get 3? This is an easy one. Since 3 is prime, the only factors of 3 are 1 and 3. 24 requires a bit more work. The factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Comparing the factors, we can see that the greatest common factor, or the greatest factor that both 3 and 24 share, is 3. That means we can factor out a 3 from each monomial. Now looking at the variables associated with each monomial, we can see that 3 has an m cubed attached to it, and 24 has an m squared and an n attached to it. Right away, you should recognize that both monomials share the variable n. Recall that exponents are really just repeated multiplication, so not only do both monomials share an n, they actually both have 2 n's, or put another way, they share an n squared. Since the first monomial doesn't have an n variable, our work is almost done. Combining the 3 and m squared, we get 3m squared, which is the greatest common factor between the 2 monomials. You should apply the same process for questions numbers 2, 3, and 4. If you made a mistake in number 1, pause the video and check your work for the remaining problems. If you are feeling confident, the answers are as follows. Hopefully the do now wasn't too difficult and you were able to follow the process of finding the GCF. Moving forward, we're going to extend our ability of finding the GCF to factoring polynomials. So to make sure we're all on the same page with respect to language, a polynomial is simply an algebraic expression with multiple terms and non-negative integer exponents. We have special names for polynomials with 1 term, known as monomials, polynomials with 2 terms, known as binomials, and polynomials with 3 terms, known as trinomials. Anything with more than 3 terms is simply referred to as a polynomial. The first method that we will use to factor polynomials involves applying the distributive property and GCF in a way known as greatest common monomial factoring. This process produces the factorization with a monomial that has the greatest coefficient and the highest degree that evenly divides all the terms of the polynomial. To better understand this definition, let's move on to an example. Factoring the polynomial 4x to the power of 5 minus 8x to the power of 4 minus 4x cubed might seem daunting at first, but in reality it's quite easy. Let's create a general plan of action for factoring polynomials. Number 1, identify the factors of each coefficient in the polynomial and determine the greatest common factor. Number 2, identify the variables in the polynomial and the degree to which they are raised. Then determine the highest degree common to each term. Number 3, combine the results of steps 1 and 2 and find the greatest common monomial. Divide each term of the original polynomial by the greatest common monomial to express your answer as a simplified factorization. At this point, I would pause the video and jot this plan down in your notes. Applying this general plan to the polynomial 4x to the power of 5 minus 8x to the power of 4 minus 4x cubed, first we need to identify the factors for each coefficient. The three coefficients in this example are 4, 8, and 4. Don't worry about signs at this point. We are just interested in the magnitude of the coefficients. Since there are two 4's, we only need to perform the factorization once, since the result will be the same. The factors of 4 are 1 times 4 and 2 times 2. The factors of 8 are 1 times 8 and 2 times 4. Comparing these factorizations, we see that 4 is the greatest common factor between 4 and 8. Step 2 tells us to identify the variables and the degree to which they are raised. All of the terms in the trinomial are expressed using the variable x. The degree to which the first term is raised is 5, the second term is 4, and the third term is 3. So the highest degree that evenly divides all the terms is 3. Remember that when you divide exponents, you subtract the values of the powers. Combining the results of steps 1 and 2, we can see that the greatest common monomial for all the terms of the polynomial is 4x cubed. If you recall, this method of factoring involves the distributive property. So when we determine the greatest common monomial, we are actually finding the term that we're going to distribute over the factor expression. When we divide each term in the original polynomial by the greatest common monomial, which is 4x cubed, we get the expression x squared minus 2x minus 1. The final factored solution would be 4x cubed times the quantity x squared minus 2x minus 1. While there are lots of steps, the arithmetic is quite straightforward. Let's do another example to practice. Let's take the expression 36x to the power of 4 minus 42x squared. Refer back to the 4 steps we utilized in the last example. First, we will identify the greatest common factor for 36 and 42. You are well practiced enough with your multiplication tables to easily recognize that 6 is the GCF. However, for good measure, you can do the factorization for each coefficient to reach the same result. Next, we address the variables and the degrees to which they are raised. Both terms in the binomial are expressed in terms of x. The first term is to the 4th degree, the second term is to the 2nd degree. Therefore, 2 is the highest degree that evenly divides into both terms. Combining the results of the first two steps, we get 6x squared as the greatest common monomial. When we divide both terms in the original expression by the greatest common monomial, we get the expression 6x squared minus 7. The final factor solution would therefore be 6x squared times 6x squared minus 7. For the first two examples, we are factoring using the GCF method. For the next two examples, we are going to revisit quadratics and practice the polynomials that have leading coefficients of 1. As we advance throughout the study of factoring, we will move on to more advanced polynomials, but to establish a strong foundation, we must first master the basics. Let's first start with the expression x squared plus 9x plus 20. If we list the coefficients of the three terms in the polynomial, we get 1, 9, and 20. The GCF among these three numbers is 1, so the technique we just learned won't apply because factoring out a 1 won't change the expression. Instead, we need to consider another root. Recall when you learned to FOIL. You were learning how to apply the distributive property to two binomials to simplify into a trinomial. Now we are working in reverse. We want to break down a trinomial into two binomials. These binomials are in turn our factors. For all the examples we are learning today, the leading coefficient will be 1, which has a factorization of 1 times 1. The identity property tells us that 1 times any value is equal to that value. Remember this point as we move forward. Now I want you to turn your attention to the degree of the polynomial. Since it is a quadratic, we know that the degree is 2, and given that x squared term has a coefficient of 1, when we begin our factoring, we will know that each binomial factor will begin with x. To prove this, remember that f in FOIL means first, and if we multiply x by x, we get x squared, so it checks. Now consider the factorization of the constant, in this case 20. The factors of 20 are 1 times 20, 2 times 10, and 4 times 5. These factors are directly related to the coefficient of our x term, which is 9. Remember, we are doing the reverse of FOIL, so we want to be thinking about multiplying our two binomials together. The last terms of each binomial factor need to have a product of 20, while at the same time, the sum of our outside and inside terms needs to be 9. Remembering what I said about the identity property with respect to the factorization of 1, we now just need to find the set of factors that satisfies both conditions. Take a look at the values we came up with. Which values, when added together, give us 9? 4 and 5 should jump out to you. These two have a product of 20 and a sum of 9. Putting all these steps together, we get a factorization of the quantity x plus 4 times the quantity x plus 5. You can use FOIL to check. Let's try one more example together before you try your hand at some practice problems. X squared minus 18x plus 32. A few things should stand out to you when you read this expression. First, it has a subtraction sign, which will require us to think differently from our first example. However, just like the first, it's a quadratic expression with a leading coefficient of 1, and the GCF for all 3 coefficients is 1. Right, so let's build off the example we just did. Let's first do the factorization of 32. We get 1 times 32, 2 times 16, and 4 times 8. Looking at these factors, we know that we're looking for a difference of negative 18 when we combine them. Right away, you should see that 2 and 16 might be viable options. Remember, we need to have the last terms of our binomial factors have a product of a positive 32, while at the same time, the difference for our outside and inside terms needs to be negative 18. You know that with multiplication, you can get a positive product by either multiplying 2 positive numbers or by multiplying 2 negative numbers. In this situation, since we have a minus sign in the trinomial, we need to consider the second possibility, that is, multiplying 2 negative numbers. Thinking critically, we can build our binomial factors, the quantity x minus 2 times the quantity x minus 16. Using FOIL to check, we can prove that this factorization is correct. At this point, you should have a good foundation for factoring using the greatest common monomials and our reverse FOIL methods. I want you to now try a few examples on your own to further refine your skills. Given the amount of trial and error and guessing and checking involved, this may take several minutes for you to complete. Feel free to rewatch the video and consult the supplementary resources to help you solve these problems. I would suggest that you pause the video and try your hand before checking your answers. Thank you for joining today. Your knowledge and command of polynomials and factoring should now be improved as a result of your participation. Please check out the links in the description below to access useful websites, videos, and supplementary information that will further strengthen your math skills. Don't get discouraged. Factoring is a process of trial and error. Having clear notes and organized scratch work will help you refine your skills. And, as always, practice will make perfect. Don't forget to subscribe for further updates and videos that will help you stay sharp and help you prepare to meet those competencies when school starts back up.